take a look at energy, right? So the energy a body possesses is defined as its capacity to do work. All right, as I said, the more work it can do, the more energy you have. Therefore, the more work you can do, the more energy it has, right? Note that the work done by an object is the product of the force acting on it by the distance moved. So if I give you an object and I apply a force to this object should move at distance d. All right? And the work done or the energy is given by the force multiplied by that distance. The SI unit is Newton meter or joules. All right? The SI unit is Newton meter or joules. All right? So for energy, the SI unit is joules. Formula F by F, right? So you're right. Remember, I gave you this handout. You know how to write all that. I want you to go take it. Anyway, go ahead and write it. Right, we're going to take a look at all the different types of energy as I move along. Just give an example of each one, right? Right, so that's energy, right? We have these different forms of energy. These are the different forms of energy here: chemical, electrical, magnetic, electromagnetic, thermal, and so on, right? Let's just talk about each one now. What's an example of chemical energy? Nuclear plants, but to be more specific, that will be nuclear energy. Chemical energy. Why do you get chemical energy earlier? Like initially from the food, right? Initially from food, it'll give us chemical energy. Then we will convert to mechanical energy. All right? From food, from fuel, that's chemical energy inside the fuel. That will be converted into heat and thermal and so on. All right? So an example of chemical energy, as we said, is the energy from fuel. Electrical energy, where we'll get up. Electricity, right? Magnetic energy. Magnet, electromagnetic. Now we from waves, like radio waves and things, those are electromagnetic. Make a note of the ones I don't know, right? A microwave, radio waves, electromagnetic. Right? Thermal. Thermal is from what? From heat, right? From a fire, right? That's thermal energy. Nuclear energy. From nuclear plants, right? From a nuclear reaction. Sound energy. Right? From a speaker box. Very good. Kinetic. Something moving. Gravitational. Gravitational energy is something above the Earth's surface. Alright, that's gravitational energy. And elastic potential. Or you'll get a rubber band or strip or something. All right? Are you okay with that? So those are the different types of energy. Now, there is one conservation that you should know, right? The conservation of energy. When you finish physics, there's one law that you should know. Right? Morning. Morning. What's up? Yeah. Okay, let's okay. Conservation of energy, right? But what is the conservation of energy? Conservation of energy, real simple. It says that energy can neither be created nor destroyed, but is merely converted from one form to the next. So if I am producing sound energy, it came from somewhere, right? Probably came from fire heat, right? Chemical energy. Okay? So energy doesn't just exist. It cannot be created, it cannot be destroyed. All you can do with energy is convert from one form to the next. So for example, if you have a car and you put fuel in it, that's chemical energy, right? And that's be converted into what? Mechanical, sound energy, right? Heat energy, right? Right, so it cannot be converted. I mean, it cannot be created nor destroyed. It's just converted from one form to the next. All right. So here we have some examples. Some examples of conversion of energy. Of course, it's just the main thing, right? Just the main form energy. Right, Joy? Right? It's just the main forms. So if you look there, a radio converts what? Electrical energy into and thermal. What you will recognize is that a byproduct of every single type of energy is thermal. Any conversion always produces from heat. Is it clock? Right? You will convert the chemical energy into mechanical clock, and you will hear what? Sound, and there is a little bit of heat. Right? So there's a byproduct called thermal energy from all conversions, right? All. What kind of? Right? Some loss of friction. If you have a gas stove, cooking on a gas stove, chemical energy into thermal energy. Hydroelectric, you have mechanical converted into electrical. Nuclear power station, you have nuclear into, I think I'm missing here. Thermal and what? Thermal and what? What's the purpose of a nuclear power station? To produce what? Huh? Electricity. To produce electricity. Right? So it will be thermal and electricity. Of course, there are other forms of energy being produced, but we just originally mean types of energy. All right? Right? So that's copy down two of those, right? Copy down any two your one. Right, so let's make a note of two of them. Any three of them. And I want you to do one for me. right? And an electric fan. Do the conversion in an electric fan. Breeze energy. Oh, yeah. All right, so what do we have there? Electric fan. What are the forms of energy? Sorry? So first thing, what is source of the energy? The electric part. Electrical energy. And the electrical energy is being converted into what? Into? By thermal. Right. Mechanical and wind energy. Right? Answer. Okay. Answer. Right? Mechanical, because the electrical turning the fan blade. And the fan blade giving you wind energy itself. Then thermal. Alright, so write up. Yeah, that's cool. Let me find out. Alright, so that is your right? That's the conversion, right? Electrical energy being converted into mechanical, and it gives you sound, heat, and thermal. Always write thermal, right? Every single byproduct, thermal. All right. Next thing we have to look at, we have to look at two main types of energy. Oh, by the way, your homework. You have to write how these three types of energy could be of benefit to the Caribbean, right? That's your homework, right? Solar energy, why is a useful alternate form? Wind and geothermal. Right? What is geothermal? Huh? No, geothermal. What is geothermal? From like volcanoes and like, right? Yeah, right. But more true volcanoes, got the crest of the bar, right? So more from volcanoes and things, right? So some countries they can harness geothermal energy. Countries like us can't. Yeah, right. So some countries they can harness geothermal. Of course, we can't, right? We can't even harness wind turbines. All right. All right, so and I'm two kinds of energy that we have to focus on, right? Most of the calculations going to have kinetic energy and potential energy, right? Kinetic energy is energy due to motion. Potential energy is energy due to position. So if I give you an object and the object above the Earth's surface and it's not moving, it has potential energy. If I release it, as it falls, it now has kinetic. It doesn't magically get kinetic energy. What happens is that some of the potential is converted into kinetic as it moves. Just before it hits the ground, what will happen? Just before it hits. Right? Zero potential. All kinetic. Just before it hits. And when it hits the ground, it will lose all the energy. Right? After it bounces and so on. So all the way on the top, it has potential energy. As it falls, it loses potential, but the potential is converted into kinetic. Just before it hits, all kinetic. When it hits, kinetic is lost to heat and sound and so on. Right? Of course, if it has more kinetic, then it will rebound for a short period of time. Okay?
So in fun, it would just kinetic energy as well?
Yeah, mechanical energy is a combination of kinetic and potential. All right. Here we have kinetic energy and the definition. We write down the formula. Kinetic energy is a half mv squared. What's the SI unit for kinetic energy? Joules as well, right? Joules as well. All right. So Potential energy, write the formula. Potential energy, write the formula. Potential energy is mg, right? Pardon me, ma'am. Who writes all that now? Is it in rules? Or the writing all this?
So, alright, also we get.
Right? Right on the formula, potential energy. All right. So that's kinetic energy and potential energy. Never finished. Never finished. We're only talking. Very true. All right. So kinetic and potential. There's one thing that we're going to look at. We're going to take a look at the conversion. Finish now. Right? So we're going to use this in some past paper type questions now, right? So remember, kinetic is when the object is moving. Potential is when it's at a position above the Earth's surface, right? No class next week. That's why I did remember that. All right. So let's go. I thought let's go write this in the group. All right. The next thing we have to look at quickly is what happens when potential is converted to kinetic. So, for example, an object as it falls, its potential is converted to kinetic, right? There is some point in time. So, imagine an object here, right? This is the ground, and the object has 10 joules of energy. Potential. As it falls, potential is converted to kinetic. So, somewhere it might have 9 joules of potential, 1 of kinetic. Somewhere it will have 8 joules of potential, 2 of kinetic. And there's somewhere probably in the middle where the potential equal to the kinetic. When that happens, we have this relationship here. Right? We have this relationship here. Potential equals the kinetic. And there's this really nice formula here that we can use to find the velocity of the object as it falls. Okay? Don't write everything, just write the formula for V. If you're writing everything, I'm going to take it off in a minute. However, I'm going to take it off in 15 seconds. Okay. Okay. So let's take a look at the question, right? How do we do? Oh, wait, before we do that, since you all like to write, power, right? Power is the last definition that we need to understand. Power is the rate of doing work. How much work they can do in a particular amount of time, right? That's the power. So the rate of doing work is the power. All right. So write that down and then let's take a look at some questions. Well, yeah, those who want added to the LMS, you will come and give say email, right? You add it to the. Cover blast the paper. And they can have 5 page. Right, those who are right the next day, just put the name here and put the email, so that you know. Right? On the LMS, you have the notes, the videos, just start watching. Right? Do it until I do the topic, right? Did I write it? All right, so let's take a look at the question now. Everybody writing? Too bad. Tell anything in the notes. A long time. Hey, we're going to find out here, right? I got my booklet. Hey, must get one here. Agora tem um keep, right? No, they can't do this, but keep sure get our own up. Right, do in lab, do 2% and then head back in the lab, right? Right, so remember we're trying to do about 3 labs today. All right, this is number 2. I don't know the year. But try this, please. This one really easy. This is the easiest question in my senior lab. Come on, see. Some other tools on, yeah, point paper. I tried that there. If you will not see it, come a little closer now. All right, only giving you a few minutes to do that. Ready? You're done? Right, it should be done with the first part. Right, density was the SI unit. Moment, Newton, and momentum, NS, right? Okay. Hurry up, do all the next part there, then let's go to our calculation. All right, let's go. No. This is only for those who write and doing lab something, right? So I already now, I want you all to start moving on. Yes. All right, let's see. Time up. So kinetic energy is defined as what? Energy due to what? Potential energy is what? Is defined as energy due to position above the Earth's surface. The formula for the change in potential energy, change in EP, is simply mass by gravity by the change in height. That little triangle is change, right? So it's mass by gravity by triangle by height. This here means change in height. Okay, because the mass can change and gravity doesn't really change, right? So what changes is the height that changes. Okay, so it's mg by the change in height. Yeah. And then done. All right, waterfalls are commonly found across the Caribbean. Describe the energy change taking place in a waterfall. Nathan, what do you have there for that one, right? What is the main energy change taking place in a waterfall? Just the main. What type of energy the water have on top of the waterfall? Potential, and as it falls, that's all. Potential turn kinetic. That's all. That's all they want because the water not really changing and evaporating, right? The water falling from potential to kinetic. Potential energy to kinetic energy. Next one. Let's go again. Next one. Okay, I will do it like this and then do it part by part. Take a little read, tell me what happened at A, B, and C. As a pendulum, right? You're doing a lot today to something about it. Oh yeah, A, B, and C. What type of energy has a A? Which one? Potential. What type of energy it has a B? Kinetic. Right? That's why it's moving the fastest. What type of energy has a C? Potential again, right? Right? Potential to kinetic to potential. Okay? Next part. Right. Next part. Another point D, for those who forgot. D is, what where D is? See you there? Right, Joy, if you look there, you're seeing D. It went A, B, C, and then went back to D. Right? You're seeing it there? Right. Here's what they asked. See what they asked in there, right? Adam, one, right? Malia. Yeah, Annalie. So, right. So let Annalie help us out here. And another point D is situated midway between A and B. Right? If the pendulum is returning to A, right? If the pendulum is returning to E to complete an oscillation, explain which type of energy is increasing and why. Right? So it returning to E. So anally, what type of energy is increasing there? It's going back to A, leaving C and going back to A. What type of energy increasing? Potential increasing. Right? So the potential energy is increasing. Why? What's the reason? Because it's slowing down and it's going to maximum displacement. Very good. That's a perfect answer. It's slowing down. So right, it's slowing down and it's moving to maximum displacement. Sure. It's slowing down and it's moving to maximum displacement. And then do the calculation there, please. Those who online message your answer, Antonius, you can wake up now. Antonius. Right, message your answer there. Last part, kinetic energy. Work out that part, then let's do our next one. Right, use the formula and work out that. Look it out. What's the name again? What's the name again? All right. Is now be online? Yeah. Oh yeah, do that calculation there, please. Finish? Oh yeah, and we finish already. Right, some low lit Malachi, and you got this name here? What's the next level? Let the name. Flip over the page. And then flip over the page. Killer. What the email? Nine. We have work out the kinetic energy there. Let's do our next one. Upside down. I take a picture. You have put on Instagram. Work upside down. It's not bad. It's not bad. I was scared. When it upside down, I find. So when it upside down, right? Please. Right, let's do the calculation. Calculation is kinetic energy is equal to kinetic energy is equal to kinetic energy is a half mv squared. So kinetic energy will be a half by the mass. Is the mass in the per SI unit? Yeah. And the velocity is 5 squared. All right. There we go. I mean, Rakaya, how much you got? 2 how much you got? Plug it in the calculator and work it out. Remember, just square the value from here, right? Should have it anyway. Whoa. How much you all got? 5 joules, right? So don't forget to square the 5, right? Don't forget to square the 5. That's what you say. Don't forget to square the 5. No? Wrong? I guess 5. No. 5 squared is 25. 25 by 1 on 5 is yeah, 5. 5. The upside up. You get it wrong.
No, I guess. I guess
Next one. Let's go again. Anybody have a socket with 2005? Yeah. That's fine.
So can you explain how you got 5, please?
So it's in a calculator, a half by 0.4 by 5 squared. Make sure you square the 5, right?
Okay,
So,
okay.
whole thing in the calculator again. Exactly how you're seeing it, and tell me what you get. Yeah, anybody have 2005 there? Alright, let's try John 2018. Right, let's do this one out here. There's a last question and we done. Mark, I can't see room now, right? Right, try to get John 2018. What is energy? Yeah, energy is what? Diana, what's energy? No way with that. I use this one here. Energy is what? The ability to do work. And the anti-unit is use. Hurry up, write that down fast. Quick. Write it down. Right, like me, write it down. John 20. Joy, you write these things down? Next one. What type of energy we have here? Radioactive energy. What type of energy is that? Radioactive decay. What type of energy is that? Nuclear energy. Radio waves, X-rays. Talk about this one. What type of energy? Electromagnetic energy. And objects in motion. Kinetic. Next one. Try the next one there.
Oh, I can, also, there is someone. Well, depends on what you want.
Are we done?
Yeah.
Sure. So the flashlight is what? Well, chemical manufacturing into electrical, and it'll give you
Light.
right. So you could say actually this is the main, right? So electrical or can't write electrical energy into light and thermal. Okay. All right. All right. Next part. Light and thermal, right? Right, so remember the last one would have been electrical energy into thermal and light, right? Finish, right? You can do it all. Huh? No, demo. Speed and velocity, no.
Alright.
Yes.
Because I like
All right, good, I get it. All right, nice. Next part here. Last part. Last part, find the maximum kinetic energy. And this way speed and velocity, right?
Okay.
Right, find the kinetic energy of what the formula we use in area to find kinetic energy. Sorry, not area. No, I want to should be under
So I guess we're going
Joy. MV squared, right? So the mass is 0.5 and the velocity is 1.8 squared. Right? How much is that? Huh? Anybody else got 0.81?
Yes, sir.
Yeah? 0.811. So the maximum kinetic energy is this part right here.
The market might.
Last part. Last part.
Next week.
Use the principle to find the maximum potential relative. Using conservation of energy to find the maximum gravitational potential. What would it be? Right? Anybody can answer, and we done. What's the answer? Right? You can go outside. Stand by the wall. Yeah. Anybody? Christian say the same. That makes sense? Right. It just converted from so the answer is all the kinetic is converted into potential. So the answer is 0.812, right? Take a back your phone, sit on you, that's bring it out to the level stage, right? I'll see everything right. Right online.